I am Arfah Alya, you can call me Alya, and now I will present to you question number 1, set 7. This image is a structural analysis of truss system. The calculation include summing moment, sigma m, force in vertical direction, sigma Fy, and force in horizontal direction, sigma Fx, to determine the reaction at the support. First, truss system diagram. The truss consists of members arranged in triangle formation. Support are located at point A and G. First, at point A is pin support, allowing both horizontal AX and vertical AY reaction. Second, at G is roller support, allowing only a vertical reaction, GY. Loads are applied at node B, C and E with magnitude of 14k Newton, 80k Newton and 50k Newton respectively. First, sum of moment, sigma MA equal to 0. Moments are taken about point A to eliminate AY and AX from the equation. Negative 14 multiply 6 minus 18 multiply 12 minus 15 multiply 15 plus GY multiply 18 equal to 0. The final answer is GY equal to 108.33 kilonewton. Next, sum of vertical force sigma Fy equal to 0. The sum of all vertical force must equal to 0. The equation is AY plus GY minus 14 minus 18 minus 15 equal to 0. The final answer of AY is 95 kilonewton. Next, sum of horizontal force sigma Fx equal to 0. No horizontal force are applied in this system, so AX equal to 0. Next, geometry of truss member. The diagram includes a right triangle with dimension 3m horizontal and 4m for vertical. Tan theta equal to 4 divided by 3. The final answer is 53.13 degrees. This angle is useful for resolving force along a truss member. This is FBD question 1 at point A. Calculate the force of member FAL. FAL represents the force in member AL inclined at 53.13 degrees to the horizontal. Horizontal force equilibrium sigma Fx equal to 0. The horizontal equilibrium equation is used to relate the horizontal components of force FAL cos 53.13 degrees equal to FAB. Here FAB is the horizontal component of FAL. Next, vertical force equilibrium, which is sigma Fy equal to 0. The vertical equilibrium equation is used to calculate FAL equal to 55 divided by sine 53.13 degrees. The final answer is 118.75 kilonewton, and that is a compression force. Next, calculating FAB. Using the horizontal equilibrium equation, FAB equal to FAL cos 55.313 degrees. The final answer is 71.25 kilonewton, and that is a tension force. Next, equation force for member FKJ. The equation is negative AY multiply 3 plus 3 plus 14 multiply 3 plus FKJ multiply 4 equal to 0. The final answer for FKJ is 112.5 kilonewton, and that is a tension force. Next, equation force for member FCJ. The equation is AY minus F1 minus F2 minus B divided by square root 3 power of 2 plus 4 power of 2 multiply FCJ equal to 0, and the final answer for FCJ is negative 31.25 kilonewton, and that is a compression force. Next, equation force for member FCD. The equation is FCD plus FKJ plus A divided by square root A power of 2 plus B power of 2 multiply FCJ equal to 0, and the final answer of FCD is equal to negative 93.78 kilonewton, and that is a compression force. Last, FDJ is equal to 0. That's all for me. Thank you.
Assalamualaikum, my name is Amirul Syahmi, and I will continue the presentation for the structural analysis of truss system for equation 1. We will briefly go through the given problem, the solution method, and the final result. The truss structure is subjected to 3 external forces: 40 kN at point B, 80 kN at point C, 50 kN at point F. Our goal is to determine the internal forces in the specific member using equilibrium equation. The truss has equal 3 meter segment and a height of 4 meters. To find force in FJ, we take moment about point E. Sum of moment E equal to 0, and then we got the equation GY multiplied by 6 minus F3 multiplied by 3 minus FJ multiplied by 4 equal to 0, and we substitute the value 75 multiplied by 6 minus 50 multiplied by 3 minus FJI multiplied by 4 equal to 0. We get the value of 450 minus 150 minus FJI multiplied by 4, and then we get 300 minus FJI multiplied by 4, and we get FJI multiplied by 4 equal to 300, and then FJ equal to negative 4 divided with minus 300, and we got 75 kilonewton tension. Next, we analyze the vertical force equilibrium equation. Sum of Fy equal to 0, and then we write the equation FEI minus F3 plus GY equal to 0. After that, we substitute the value. FEI minus 50 plus 75 equal to 0. FEI plus 25 equal to 0. Rearranging the value, and we get FEI equal to negative 25 kilonewton. Since the force is negative, this means the member FEI is in compression with a force of 25. In summary, we solve for the internal forces in the truss structure. Our key findings are FJ equal to 75 kilonewton in tension, FEI equal to 25 kilonewton in compression. That's all. Thank you.
Hi, so I will continue the presentation by solving the question number 2. So the first step we need to do is draw the FPD of the question. So since it don't have any thickness, so it will be a straight line. Then we need to add the force reaction, the reaction at point E and F. So since E and F is a pin joint, So it will be got the EX and EY for point E, and got the FX and FY for point F. After we get that, then we're going to find the reaction at the force E and Y. So for point E, we're going to use the equilibrium equation, which is we know that moment is equal to force times distance. So we're going to use the equilibrium moment equation for point E. So sum of moment at point E is equal to 0. Then we're going to combine all the force times distance at this drawing. So we will get negative 2,400 Newton times 3.6 meter plus Fy times 4.8 meters equal to 0. Then we're going to solve it. Then we will get the Fy equal to 1,800 Newton. After that, we're going to find the Fy. Since we got the Fy answer just now, so we're going to find the Ey answer, the force at Ey. So for force at Ey, we will use the force equilibrium equation, which is the sum of Fy is equal to 0. So we combine all of the force at y-axis, so we can get the Fy plus By minus 2,400 equal to 0. So it will be 1,800 plus Ey minus 2,400 equal to 0. So Ey we will get 600 Newton. So based on this question, we don't have any clue for the EX and FX or axis, force at x-axis. We will assume that EX and FX is equal to 0. After that, we need to determine all the force at point A, B and C. So we will start by using the point, start from point B to D, since we have the point B, C and D at that line. So we will use the sum of the moment also. So sum of the moment equal to 0. So this time we will start at the sum at, we will count the moment from point B to get the C. So it will be 2 minus 2,400 times 3.6 meters plus Cy times 2.4 meter equal to 0. So we will get Cy is equal to 3,600 Newton and is a tension. So to find the By, we need to use the equation equilibrium at force Y, which is will be sum of Fy equal to 0. So we will combine all the force at y-axis. So it will be By plus Cy minus 2,400 Newton equal to 0. Then we put the Cy answer just now. By plus 3,600 Newton minus 2,400 Newton equal to 0. So By will be negative 1,200 Newton, which is a compression. After that, we're going to find the force at point E. So for point A, we need to use the FPD from point A, B and E. So since we have the By and Ey answer just now, so we can get the Ay. So for Ay, we're going to use the equilibrium equation also, which is the sum of Fy equal to 0. So it will be Ay minus 1,200 Newton plus 600 Newton equal to 0. And Ay will be 600 Newton, which is a tension. After that, we're going to combine all of the answer we get just now. So we get the Ay is equal to 600, Cy equal to 3,600 Newton, and Ey equal to 1,800 Newton. And then this is the extra equation to find the angle at point F, like at the BC, and then angle at point A. All of these clues we're going to use for the equation for the sum of for sum of the moment or sum at force. So thank you.
Hi, Assalamualaikum. My name is Nur Fatin Syazwani binti Ahmad Hairul. My metric number is B14241047. So for the third question is frames and machine. I will explain how to solve the question. Let's look at the question first. Okay, so the compound shears are used to cut metal parts. Determine the vertical cutting force exerted on the rod R if a force 100 Newton is applied at the grip G. The loop CDE is in smooth contact with the head of the shear blade at A. Then look clearly at the question. This part is keyword for the question. So we need to determine the vertical cutting force exerted on the rod R. As we know, the question already shows the force is 100 newtons. Now, look at the diagram. First, we need to find FBC. This part for member AG, AX and AY. I draw the FBD to show at you guys. Now, you see, easy to find FBC. Member AG, AX, AY. So, the solution is YF because this is force. So, F multiply 0.42 plus 0.06 minus FBC multiply 0.06 sine 16 degree equal to 0 and FBC equal to 100 for force multiply 0.42 plus 0.06 divided 0.06 sine 16 degree. So the FBC is 923.8 Newton. Let's move for the other part. This is a FBD for the loop dx and dy. So FBC multiply 0.15 minus NE. N stand for normal force at point, E for this one. So minus NE multiply 0.15 equal to 0. NE equal to FBC multiply 0.15 divided 0.15 and we get the answer is 1, right? Okay. So NE equal to FBC. FBC is 923.8. Then NE is 923.8 Newton. The answer is same. Check. And last for the head, Fx and Fy. So negative 923.8. Why negative? Look, 923.8 is NE. NE negative because it's down. So negative 923.8 multiply 0.75 plus 0.15 plus 0.75 multiply NR equal to 0. NR for this one. NR move forward and negative become positive. So 923.8 multiply 0.75 plus 0.15 divided 0.75. Press calculator and it will get NR 1109 Newton. But if you change the answer to Kn, you will get 1.109 Kn. So that's all from me. Thank you. Bye.